This is part 2 of the Properties of Polynomial series, and in this video we are going to be focusing on these three graphs down below to answer these three questions up at the top. Now, we talked about in part 1 how if all we have is the picture, we can't know too many exact things about our polynomial function, but we can figure out some things. So one of the main things we're going to work on for these three is finding out what is the x value or an estimate of the x value for the turning points, and we'll talk about what that means. We've already talked about what the zeros of functions means, so we're going to estimate those values. And then we also mentioned how because we don't have the actual function, we can't tell for certain what the degree is and what is the max number of zeros the function could have. But we can figure out the smallest possible number based off of just the graph alone, and we'll talk about how to do that. So with that said, let's get started with our first graph. So here we have our first graph. You can see we've got all this stuff going on here. And the first thing we want to do is estimate the x value of turning points. Well, what are turning points? Turning points are parts of the graph where the graph changes direction, hence turning point. Think about you're driving a car. You're going in this direction up the graph, then you hit a turn, so you got to change the direction you're going in. The turning point would be this area right here. And then we're going down, 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 until we get to another turn and we have to go back up. So we have another turning point. So turning points are basically just where the graph changes direction. You can think of them as mountains, and you can think of them as ravines or canyons. And these have other names besides turning points. When they look like a mountain like this, they're considered a relative maxima. Relative because it's only a certain area, it's not over the entire graph, and maxima because it's a maximum value. Then as we go down, you can probably guess what this will be called. This is called a relative minima. Relative because it's not over the entire graph, it's just a small portion, and minima as in minimum. It's a minimum value at that area. So we've got turning points as relative maxima, relative minima, and our goal is to estimate the x value of these turning points. So let me highlight them. I got one here, 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 there, and finally there. We have 6 turning points in that graph. And if we're going to estimate the x value, all we care about is the x-axis. We don't care how tall or low they get, just where on the x-axis are they. So I'm going to label these 1, 2, 3, 4, 5, and 6 so that we know which one I'm talking about. And let's look at that first one, number 1. If I'm going on the x-axis, I go -1, -2, -3, and then this one looks like it's between 3 and 4 somewhere. Now we can't get too precise because we don't know exactly where it is, so that's why we're estimating. And I would say turning point 1 is at about -3.5. So I'll say -3.5 for 1. Now we'll go to number 2. That's down here, and it looks like it's between -2 and -3. So we can call that -2.5. Then I've got number 3 here, and it's really close to being on -2. Okay, you might want to say, oh, it's a little bit closer, or a little bit off of -2, but if you don't want to be guessing like -1.9 or -1.8, you could approximate saying that, oh, it's at about x equals -2. For number 4, all the way down here, now this one looks like it's definitely on x equals -1. So we'll say that that's at -1. Number 5 looks like it's at just about x equals +1. So we'll put a +1 here. And then lastly, number 6, all the way down here, and it appears it's at x equals +2. So we'll say that this one is positive 2. And there we have our 6 turning points with estimated x values. Now you could have written these as x equals negative 3.5. You could have, but I wouldn't have put them as coordinates because we have no clue what the exact y values are. So x equals negative 3.5, x equals negative 2.5, and so forth would be just fine. Now that we've taken care of those turning points, let's go to the estimated x value of the zeros. So let's erase what we have. Whoops, didn't want to get rid of all of that. Let's try that again. Let's just erase this. And I don't need these anymore. Okay, erase those turning points, because I don't care about the turning points anymore. Now I care about the zeros. And hopefully you remember from a previous video, the zeros are where we cross the x-axis. So one here, here, there, and there. I have 5 zeros going on in this graph, and if I want to estimate the x value of those zeros, it's going to be exactly the same as what we did for the turning points. Just approximate where on the x-axis these are. So I could say I have a 0 at x equals negative 4, x equals negative 3, x equals 0, x equals, okay, and then after 0, look where this one is. It looks like it's kind of in between 1 and 2, so we can say x equals 1.5, and then finally here, this one looks like it's kind of between 2.5 and 3, so you could say 2.5, but I'm going to say x equals 2.75. I'm going to try to be a little more precise there. And that's all we have to do for these. Same thing as the turning points. Just estimate where on the x-axis it is actually happening. Which now can take us to our final question we're being asked to solve for. Determine the smallest possible degree of the function. So let me erase these. And I'm going to leave my marks for the zeros because, as we remembered earlier, the number of degrees in the function tells us the maximum amount of zeros. But I have no clue what my function actually is. I just have this picture. So I have to go off of the number of real zeros that I have in order to estimate the smallest possible number of zeros. So since I have 1, 2, 3, 4, and 5, I must have at least a degree of 5. So my smallest possible degree is, I'll write this in here, smallest possible degree equals 5. And that's all because I have 1, 2, 3, 4, 5 real zeros going on here. And we could say one more thing about it, about how, oh, this is going down to negative infinity, this is going up to a positive infinity, so I'm going to have a odd degree anyway, which 5 is, but still, we can't say anything more than it's just that's the smallest possible degree. Alright, we're done with this example. Hopefully the next two don't take as long, so let's try with those. Shrink this down. Let's bring this guy out. Oops. Had a little problem with my zooming there. Alright, now let's try our second example. Just like before, we want to look at those turning points, so let's identify them. They're either mountains or ravines. So I've got a turning point here, here, and there. This one looks like it's at about x equals negative 2. This one down here looks like it is at about x equals 1. And now this one up here is somewhere between 2 and 3. So depending on how precise you want, you can give a number between 2 and 3. My estimate is going to be it's at about x equals 2.5. So there are the turning points for this function. And in case you want to challenge yourself even more, this would be a relative maxima, this would be a relative minima, and this would also be a relative maxima. Alright, now let's talk about the zeros. It looks like I'm only going to have 2 zeros this time. And where do they happen? This one to the far left looks like it's at about 1, 2, 3. It's at about x equals negative 3.5. And that's a terrible color. Let's fix that so we can see that better. X equals negative 3.5 for this one. And then for this one, it looks like it's between 0 and negative 1. So we've got x equals negative 0.5. We don't have any more zeros, so now we can move on to our last part, which is determine the smallest possible degree. And just like before, I only have 2 real zeros, so my smallest possible degree must be 2. And we can tell, just like before, this side's going down to negative infinity, this side's going down to negative infinity. Since they're both going in the same direction, I must have a degree that is even, and it's at least 2. It could be bigger, but it's not going to be smaller, because I have at least 2 real zeros. Alright, pretty good. Let's do our last example. So we'll erase. And we can shrink this back down. Bring this guy out. And hopefully zoom him back up. There we go. Alright, the final example. Let's do this. Let's label our turning points. I've got 1, 2, 3, and 4. 4 turning points, so my estimated x values of these turning points for this one. So let's see, it's between negative 1, negative 2, negative 3. It's between negative 3 and negative 4, so we'll say x equals negative 3.5. Here, it looks like it's really close to negative 3, so I'm going to say x equals maybe negative 2.9. Here, it looks like it's just on the line, so that's x is at negative 1. Let's make that better, negative. And then here, we've got it between 1 and 2, so we'll say x equals 1.5. There are the 4 turning points in this function. Now, let's talk about the zeros. I have what appears to be just 3 zeros as it crosses the x-axis 3 times. Right here, it looks like it's happening at just about x equals negative 2, so we'll say x equals negative 2. Here, it looks like it's crossing at 0, so that's just x equals 0. And over here, it appears to be between 3 and 4, so we'll say x equals 3.5. And now when we're determining our smallest possible degree, I only have 3 real zeros, so we have to say that the smallest possible degree is 3. And we can be supported by that with how this side goes down to negative infinity as x approaches negative infinity. This side goes up to positive infinity as x approaches positive infinity. So they're moving in opposite directions, which means we have an odd degree. And just like I've said before, it might not be 3, but it has to be at least 3, so 3 or greater. And we know it's going to be odd. So there you have it, some other properties of polynomials and how we can use just the graph to learn more about the graph and the function than we might have thought possible. Hope you enjoyed, and good luck.